So we're starting to tie together things from the beginning of this course and things here at the end of this course. Way back in the second or third week, we talked about quantitative variables and we plotted them with histograms. We looked at whether they were unimodal or bimodal or multimodal, whether they were symmetric or maybe skewed to the left or skewed to the right with tails. Well, now we can use those ideas. A reason we built that foundation is because now that we know what random variables are, we can talk about the distribution of random variables. And we describe the distribution of random variables with exactly those terms and ideas. And it's really helpful here because here we're not just looking at what the data reveal from a sample. Here we are thinking about how likely certain things are to occur. So we can use this as part of kind of a prediction or explaining whether it's academic research or ways to think about what sort of route will make me less likely to be late for class when I'm driving from Nashville to Bowling Green. So we're going to be talking about distributions to start with that are symmetrical and unimodal. So I usually call these well-behaved, pretty, nice-looking. They're subjective terms, and it's not really fair. No distribution is more pretty than another, except in the sense that I, like many researchers, have a bias toward distributions that are unimodal and symmetric because they're the easiest for us to work with. They're the most tools available for us to use without having qualms and qualifiers on those. So that's why I describe something as being a pretty bell curve, right? And what I'm talking about there is a normal distribution, which is a specific type of unimodal symmetric distribution. It's one that we've seen before, we've drawn on the board many times already in the class. Something that is shaped kind of like a bell, comes up to one peak. It has kind of shoulders and it comes down on the other side. It's got tails going off on either direction, but it's symmetric, so it's nicely shaped. It goes up to a peak in a similar manner from each side. Normal distributions are really nice and really powerful when it comes to statistics. So a normal distribution, it has a mean that is very close to its median, which is right where the peak is. So actually the mode, the mean, and the median are all roughly the same. If we're talking about something like an ACT score, if the peak of a distribution of ACT scores is at 20 points, then that means the median is at 20 and half of the test takers are below that and half test takers are above that. Means that the average is right around 20, and it means that that is also the most common. The mode, the peak is there around 20 as well. And so things like standardized test scores often follow something that looks a lot like a normal distribution. We treat it as a normal distribution, a bell curve. There are a lot of other phenomena that take roughly a normal distribution. If we look at the height of people in general, if we have a big sample, we'll have something approximating a normal distribution describing the height. If we look at a lot of other measurements in nature, so we see a lot of things like that. We'll talk a little bit more next week about why normal distributions are really important in statistics, not just because we see things that look like them, but because they help us think about uncertainty of what we do in a really powerful way. But for now, we're thinking about normal distributions. We're thinking about those unimodal, symmetric, pretty things. And in our next little video, we'll be talking about what we can do with that when it comes to pinning probabilities down, thinking about how likely or unlikely something is to occur.